Hello everyone, welcome back to the second episode of All-Gen Tutorial. It's Sharif from Rebel Technology, and today we're going to show you how to make a very simple delay. So let's get cracking. So first things first, let's rename this. So we're going to go to simple delay on the example patches and this. Okay, and then let's open up the gen file and unlock this, and then save this as simple delay as well. I'm going to close this and then unlock max file and then rename this gen file like so. Then open again and then unlock this. Okay, so the first object that we need is delay, and then you need to add the first argument, which is your max delay length. And since OWL runs on 48K, we're going to add 48,000 and then set this attribute feedback to 1. It basically changes this delay object's mode to accept the feedback, which is going to be handy in a second. So we're going to split what's coming in from OWL. So that's your dry signal, and that's going to be your wet signal. So the first thing we want to control is your delay time. So all the value input from the OWL, not the audio input, but the data or CV input from OWL, works on the value between 0 and 1. So 0 being the lowest voltage and 1 being the highest voltage. So basically the first problem that we're going to encounter is, because we set the max delay time to 48,000, but this box on the output's value between 0 and 1. So we need to scale this. So the first thing we need to do is to multiply and then 48,000 and connect it to your delay time. However, we're still gonna have a problem, because since the gen works on the audio rate, any value input which is done by human hands will have this really bad, very stepped control, because working on audio rate means basically the value will be updated every sample. So if you're working on 48K sample rate, that means the data update happens 48,000 times every second. So I'm just going to quickly show you what this actually means. So I'm just going to add another output, plug that in, then go back to max, and now you can see the third output just appeared on your gen object. So I'm gonna add scope tilde and then plug that in, and then I'm gonna hit Command I and then change this display ratio to 0 to 48,000. And then you make sure your DSP is turned on your max. You can either turn it on by hitting your easy that object, or you can turn it on and off here. And then when I turn the dial A, which is connected to the delay time, and now to the output 3, you can see all the value that I put on goes on the little ladder steps. And this, what's going to happen is, if you leave this as is, when you change the delay time, your delayed signal have this really horrible glitchy sound, and we don't really want that for our delay. That's not nice. So we're going to insert, oh, by the way, this is a very cool new feature. They added on Max 7. Now you don't have to unplug your patch cord in order to insert a new object in between your objects. In order to do that, you want to select your patch cable by either dragging your mouse over while holding down Alt, or simply click on it and then hit Shift N. This will insert a new object, and then you can just type in. So now what we need is some sort of slew object, and Jen already has this, which is called slide. And what slide does, it says filter signal logarithmically, but in the layman terms, this is basically your slew limiter. So basically you can type in 2 arguments. The first value will be your ascending slew rate, and then the second one is your descending slew rate. And what's going to happen is the smaller the value, the quicker the slew, and the higher the value, slower the speed of the slew. So what I'm going to do is I'm going to just type in 3000 and 3000, and then plug the output into the output 3 on the Gen. Go back to max and then check. There you go. Now my values are much smoother. There's no more steps. And so when you change your delay time, the delay time changes smoothly, and what's going to happen is you're going to have your tape-like sounding delay with a pitch shift. So that's been sorted. So let's get rid of this. One thing to note, when you design things for OWL, please make sure you only have your 2 audio inputs and 2 audio outputs in these param box for your CV inputs, because if you change the number of these inputs and outputs, when you try to compile it on hoxonowl.com, your code won't compile. So the second thing we want to do is to have your feedback. So what we need is another multiply object that goes in there, that goes in there. This comes out and then goes back in. Let me just do this so we can see it properly. And then we're going to want our, that's your dry, and this is a wet. So again, Jen have a very handy object called mix. And what mix does is it takes in 2 signals. So first inlet on the left is 0, and then the second one is called 1. And then the third inlet let you interpolate between that input 0 and input 1, which means you can basically crossfade between 2 signals. So let's put this here, then put this one here, that goes out. Let's just make, let's just make a little bit more space, and then I'm just going to grab Control D and then go in there. This is the simplest way to create a delay, but let's spice up things a little bit, because we could make, what we can do is to insert a low pass filter between your feedback control and your delay. So let's move this down a little bit. And then we're going to insert a low pass filter here. But inside Gen, loads of things that you kind of have to do it on your own. And one of the things that you have to do it on your own is to create a filter. But what we need for this is a very simple filter, which is the one pole low pass. And you can actually find the actual diagram of how to design this filter on this one pole tilde MSP object. So let's open up a file. And there you go. On your top right corner. So that's your one pole low pass filter diagram. So what happens is the signal comes in and then have the feedback, and then it goes through this Z-1 means that's basically add one sample delay, and then it feeds back, and then you have your amount of the feedback that's going to happen, and then these two signals are blended and then comes out. So that sounds simple enough. So let's get rid of this, and then let's go back to our gem patch. So first thing we need to do is to add mix, so we can mix the original signal and then have a one sample delay signal fed back into the signal path. So in order to add one sample delay, you can use delay inside your gen patch, but because Cycling 74 guys primarily designed gen level to give people flexibility to design their own filter, so they added this new object called history, which specifically adds one sample delay. So let's use this, because history becomes very, very handy in loads of time when you design things in Gen. So that becomes your best friend. So now we have a history, so we can feed that back straight away. And then let's route this so we can see this properly. And then let's use our parameter C to control the amount. The whole point of having this feedback loop, so in order for the low pass filter to work, the delayed signal has to be always mixed with the original signal, which means the controller value cannot go above 1. So what we're going to do is we're going to insert another object here, and then clip the value between the 0 and 1. So it's getting a bit cluttered, so let's make a little bit more space. Okay, push this down a little bit more. Okay. Oop. Let's push this down a bit more. Like that. Okay, so the signal comes in, being delayed, and then goes through a low pass filter, and then it's going to be fed back. And I'm just going to add another clip object here, so the feedback loop will never blow up. Then I'm just going to clean this one again. Okay, so this looks all in order. So what we need to do, because OWL is a stereo channel, so what we can do is to duplicate this, move it over here, and then connect all of these controls. Just fits like that. Okay, so now we have a stereo simple tape delay. So before we export this, let's make sure this works. So let's drop some audio, hit loop, and then turn each knob. Okay, so that's all working perfectly fine. So I'm just gonna add a message box and add export code, and then click on it. This will ask you where to store. So let's go back to the original folder. Then let's create a new folder called code, and then hit open, and just let's check it's there. Yes, they're both there. You have your .h and .cpp. Those two files are what we need. So let's go to hoxtonall.com, and then if you log in and go to my patches, you will see this big button says create patch. So click on them, and then let's call it simple delay, and then let's choose files, then select those two files, and make sure you change your compilation type to gen, then hit save and compile. Okay, once that's all done, make sure your OWL is turned on and connect it to your computer. Once that's done, hit connect to OWL. And once it's been connected, your button turned into load button. So let's hit this, and let's wait. And great, that's all looking fine. So let's check if it's working on the hardware. So here we go. So I've just created a little sound. It sounds like, there you go. Let's speed that up a little bit. Okay. And then And that's all working, so that's great. Well, there you go. That's how you make your stereo dub tape delay. Thanks for watching. If you have any further questions, please let us know, and don't forget to subscribe, rate and comment. We're going to be back soon to do more delay tutorials, because we can add other stuff like the tap delay and the crossfading. So stay tuned, and happy wiggling and happy patching. I'll see you soon. Bye.